Okay, welcome back. So we have a fantastic session lined up for you this afternoon. We have three practitioners of visualization, people that have constructed lots and lots of really informative and beautiful visualizations. And the first speaker today is going to be Katy. She's a professor at the University of Indiana. And some of you, probably many of you, may know that she has done quite a lot of work on the science of science and mapping science. She's produced a book called The Atlas of Science that really lays out how different topics in science and different practitioners of science connect with one another. Today, she's going to be talking about data visualization literacy, and well, I'll invite you up to the stage, Katy.
Good afternoon, ladies and gentlemen. I lost my voice yesterday, so I'm going to use this microphone extensively to make it through the talk. It's a great pleasure to be here. Thanks so much for the organizers to bring us all together. I get to see some of my heroes and friends and colleagues, which I don't get to see so often here. I will start with the statements that many people love maps. They are very much admiring maps. They know about the value of maps. They know that these maps, even though they were not perfect to begin with, have helped many to find back home. They have helped many to understand where the monsters are in our world or in science. In the world of science, there are maps of science which have monsters as well. They have now also embraced these new maps of science, maps which show where collaborations take place, maps that show where our taxes are spent, maps that show who claims what intellectual space and what patent mills exist, how different companies compare to each other in terms of their patent portfolios. They love maps that show them the mood of a nation over the daytime and see kind of grumpiness and happiness sweep over the US, for instance, in this particular visualization. They are interested to understand how different areas of science evolve. Here is a map of the emergence of nanotechnology, how different journals play very different roles over time. They also like maps of the future. They would like to understand what the world in 50 years will look like. And this particular map, which was created for a UK client, shows a 50-year outlook into science and technology. And there are wild cards, but it is a very ambitious map to create. People also like maps of science fiction books, and some of you might know of some books and might find them on these maps, and close by books will be probably also interesting to you. And all of these maps can be explored online, and if I would be in the entertainment business, I would just continue showing you maps, and I think this would be just fine. But I'm here as a researcher, so I'm going to stop showing maps, but maybe show you a few more interactive data visualizations we now also have in the Mapping Science exhibit. So we have maps of scientific data, of wind patterns, water flows, of particulates which are going around our globe. We have interactive maps of all the National Academy reports. And actually there's an interactive display of all these reports close by to here. There are interactive maps of news mentionings around the globe. And again, all of these interactive data visualizations can be seen in the Mapping Science exhibit. Ultimately, you can also use Twitter data and other social media data to see what you would smell in a map. So this smelly map actually shows you where the green areas are in London and where the more congested areas are, where the areas are where there's good food smell and other smells. You can also use data on traffic patterns, commuter patterns here, to redraw the boundaries of the states in the Americas. And it's interesting to then zoom into your state and really see how many people actually are commuting long distances every single day. And again, this is not a talk about maps of science, but it's a talk about the power of maps and the real interest that people have in these data visualizations. And oftentimes, maybe they trust them too much, because as we have seen, not all of these maps have always been correct. In some cases, we know it's only mapping English-speaking data. It's not mapping all of the other languages that also produce very valuable scientific and other results. And the real problem is that data visualization literacy today is rather low. We recently ran a study across 6 science museums in the US, interviewing 1,000 youth and their caregivers, trying to understand if they could read maps that I find rather trivial to use, and that all of the people I surrounded myself with can read. But those which make it into science museums, when confronted with a scatter plot or when confronted with a proportional symbol map, many of them cannot read these maps. If they're high school students, if they're in a STEM job, they can read them. But most of the people which make it into science museums might not have these jobs or these occupations. And so what do we do then if the data visualization literacy is so low, but yet all or many of us believe that in today's time and age you have to not only read and write text, but you also have to read and write data. And you need to read and write data not only for your job, but also for your personal abilities to deal with, I don't know, with your finances, with your health, with other issues in your life that are very important to understand and to make data-driven decisions on. And so let me show you some of the research, and it beautifully builds on what just happened in the session right before. That tries to, first of all, define data visualization literacy, but ultimately also aims to improve data visualization literacy and helps to empower many to render data into actionable insights. And so in our research, we define data visualization literacy as the ability to read, make, and explain data visualizations. And we believe that requires that you can read and write text, because many of the data visualizations have axis labels, they have titles, they have text surrounding them. You also will need some visual literacy because it's composed in a certain way. Different colors are used. You have to interpret and evaluate and create these visualizations. And you also have to have data literacy. If you have a scatter plot, you have to understand what a dot means that's placed inside of that square, which is defined by the axis. Now, many scholars in data visualization, cartography, scientific visualization have tried to bring order to the many data visualizations that now exist. And there are many different proposals on how to bring order. And it's very much like trying to organize all the many animals or trying to organize all the chemical elements. There needs to be an ordering principle ultimately that helps those which are non-experts to understand how to name these things, how to make them, how to use them, and when to use them. And so existing proposals looked at organizing all the many different visualizations by user insight needs, by the different tasks that users are trying to do, by the data to be visualized, by different data transformations as we saw in Jeffrey Hare's talk, by the different visualization techniques and algorithms used, by the mapping transformations, or by the interaction techniques. And there are many other proposals as well. Ultimately, I believe we need a multi-level system to really help people make sense of it. And so what we encountered in our work over the last 20 years now is that oftentimes people come with lots of data, and ideally it's digitized. It's not that we need to encounter something like that. we then also notice that people oftentimes want to answer these when, where, what, with whom questions. They want to answer temporal, topical, geospatial, and network analysis and visualization questions. Ultimately, they want to find their way through the data or through a large area they are interested in exploring. They want to find collaborators and friends, that's where networks come in. They want to identify trends and outliers and patterns in the data. And we have been trying to develop descriptive and predictive models and all the other elements that are needed in order to read and write data, to pre-process data, to analyze data, to then ultimately also visualize data that helps them to get from that data to the insight needs they really have. And oftentimes our clients, they come with different levels of needs. So they might have very individual needs and very small-scale data sets. Maybe you can even map them by hand. If you have a small family, maybe you can make a network of who likes whom by hand. In some cases, they have an entire data set of a university or a geospatial region. So these are at the local or group level. Then you have institutions like the OECD that really look at global data, all of science, our entire world. And so you have these different levels of analysis. And if you now take those two axes and you compose them into a table, then you have levels of analysis from micro to macro, and you have these different task types from statistical analysis, which we saw quite a bit today, to temporal analysis, bursts of activity, trends, seasonality effects, to geospatial analysis, where you would go to cartographers or geographers to get advice. You have topical analysis. Much of this algorithmic framework has been developed by linguists. You also have network analysis. And of course, you also have models, which I'm not going to address today. Now, coming from a stakeholder perspective, you would then start to set up a framework where you identify the needs and desires of stakeholders. You would then try to get your hands on the best data that you can afford in the time and with the resources you have. And then you would read that data, analyze it, and visualize it. 1, 2, 3. You read, you analyze, and visualize. In fact, I've never seen a data set that I didn't have to analyze first. I can't just take a data set and visualize it. I have never had the luxury to have such a data set. So it has to be simple as these 1, 2, 3 steps. There's also a 1, 2, 3 step sequence for visualizing data. So here you would pick a reference system, you would overlay the data, you would use the positioning to visualize the most dominant part of your data. And then you would use color, shape, and size coding and other encodings to visualize secondary data variables. Ultimately, you would deploy it on a large display wall. Might be printed. You might have it on your phone. All these different deployment options have huge impacts on what kind of data you can visualize in what way. Then after you deploy it, you show it back to yourself or to your stakeholders, and you might realize, oh, there is data missing, or I really want to zoom in here, but now I need to get more data. Meaning that you go in that cycle many, many times. So it needs to be easy for you to go from reading to deployment of data and data visualizations very, very quickly. And there are different types of reference systems, including geospatial or networks and others. Now, in the visualization frameworks that we have developed and are now implementing in different environments, we distinguish different insight need types, different data scale types, and we already got a perfect explanation of those in the previous talks. We also distinguish different visualization types and notice that there's no agreement even among the visualization experts on those data visualization types. We might name them differently, and we might also use them differently. However, I think it's our responsibility ultimately to bring order to all of this so that it's easier for others to use that framework and to use these tools effectively. We also distinguish different graphic symbol types from points and lines, such as other geometric symbols, to linguistic symbols and to pictorial symbols. And you have different graphic variable types that can be used to then encode further variables with those graphic symbol types. Ultimately, you also have different interactivity types. If you just print something, you can very easily zoom by bringing it closer to you. But if you have it on your phone, you might like to zoom in a different way. Now you can look at any of these columns and you can see prior work. And again, there are many, many heroes of mine and other experts still alive which have really worked hard to bring order to all of this. And here you see some of the approaches, starting with Jacques Petit's seminal work, to some of the tools which are also out there today, which also try to make it easy for users to understand when to use what kind of visualization. To, on the right-hand side, the different types of insight need types that we are using. You can also take two of the columns and you can again create another table. So here you have graphic variable types versus graphic symbol types. And we already know that there are points and lines and areas, and we already heard in the previous talks that spatial is very, very dominant, and then size and shape and colors are very easy for us human beings to distinguish and use. But there are actually many, many more that you can also use, including, again, linguistic symbols and pictorial symbols, which can also be color-coded, size-coded, etc. And there are many optical and motion features which now, with interactive data visualizations, can be easily implemented. And this table alone, making sure that we really understand which features should be implemented when, that's many, many different PhD theses right there. Or you automatize the entire approach, and I would love to talk more, because you could potentially try to use examples of what has been done before to understand or help us all understand which kind of visualization is most insightful. Now we have had the luxury with funding from the National Science Foundation and others to implement this kind of framework and tools to make it easy not only to teach this framework but also to then help people go from data to visualizations. And it's really not just tools, it's also methods. And so in the information visualization MOOC, which we have been teaching for 6 years now, so the current course is running if you want to come in and look at it all. We have students from 100 countries come in every spring, and these students go through a sequence which is very much defined by the visualization framework. So again, you get to work with temporal, geospatial, topical, and network analysis and visualization frameworks and associated algorithms, methods, and workflows. And you render different types of data in these different types of visualizations. There's also a client project at the very end where students work with real-world clients on real-world projects. Even the textbook uses that framework as an organizing principle. You also have flashcards, because I believe that the 60 visualizations which you can kind of learn how to name and learn about their types and when to use them and not to use them, we need to agree on the names for those visualizations. If you cannot name something, you have a hard time talking about it. You can try to explain what you are referring to, but it's so much easier if you actually have a name for it. And so all comments, again, are welcome. If you have a favorite visualization that's not covered there, please let me know. The tool that's used in the MOOC also implements the framework. And so you see, again, you have data preparation. Well, first of all, you have to load your data. Then you have to do a lot of data preparation. I always tell my students that 80% of their final work will be cleaning data. Cleaning data, linking data, aggregating data, putting some new data in to do geolocation, for instance, or science location. And if you don't like cleaning data, there are doors over there, there's another door. If you don't take good care of data, everything else will be bad. So you really have to make sure that the data you have in hand is the best it can be and that you truly understand the problems, potentially also with your data. But then you go from pre-processing, where you, for instance, for networks, you might like to extract the top nodes, you might to delete isolate nodes, etc. So there are many ways that you can pre-process networks. Then under analysis, again, you have temporal, geospatial, topical networks. And for networks, again, you have different algorithms that are meant for analyzing unweighted and undirected networks, and weighted and undirected networks, and so on, until you get to the networks that have weights and have directedness. And ultimately, similarly for visualization also, there's the same process in place. And here we interlink to a lot of different algorithms, including these three algorithms, of course, and also integrating entire tools such as GAS or Cytoscape. And ultimately, students get to understand that they can read in one CSV file, here, for instance, with publication data, and then they point the tool to one or two different columns in that CSV file to, for instance, run a burst analysis, to look at sudden increases of usage frequency of keywords or citation counts towards a paper, or to point it to an address, to do a geolocation, and to ultimately map it in geospace. You can also extract all kinds of networks. You could point it just to the coauthor column, extract the coauthor network, animate it over time, if you also pointed the tool to the year of the publication. But you can also extract all kinds of bimodal networks. So how do we now go from advancing data visualization literacy in a classroom setting or in a MOOC setting to really getting to the much broader population which are outside of the K-12 or undergrad, graduate education? And so here we recently received funding from AISL, and this is really a collaborative effort with Kylie Pepler at IU and Brian Kennedy from the Science Museum in Minneapolis, Stephen Utsu at the New York Hall of Science, and Joe Heimlich at the Cozy Science Museum, where we are trying to bring data visualizations to the museum floor. And this is not easy, because on the museum floor you have maybe in one corner rockets going off, so it's loud and it's fire and it's amazing. And in the other corner you have these very cute little animals with big eyes. And in the middle is our data visualization. And we want them to come over to us. And one way to do this is to personalize this experience, to make people volunteer their data so that we can show them themselves in the data. The other part is that people like to construct and they like to build. And so by them constructing data visualizations, not just reading them, but really making them, I think that's another very important piece that we bring to the table. And so here we have a run exhibit where there are two trails, and there are always pairs of two, or maybe it's just one. And you can select whom you want to run with, and I have a little animation of this in the next slide. But ultimately, you get two data points this way. One is that we actually measure your height, because if you're this tall or that tall makes a difference. And we also measure the distance or the difference between your start and end time. So you have these two values, and you can immediately create a scatter plot from those. And then after you have done your running for 5 times, or if you are really young and energetic, for 10 times or 20 times, maybe you want to sit down. And so we have another corner for you where you can actually look at your data in a more systematic way. And so the run exhibit itself looks like this. So you can select a mascot, you can select a very famous runner, or you can also select T-Rex, which is actually very popular. And ultimately, you get to see yourself in that data, because you just see yourself as a kind of new data point and actually a splash in our implementation in the data itself. And then again, after you have exhausted your running energy, hopefully you have some mental energy left, and you can go and volunteer more data, such as, for instance, shoe size. Apparently, people are very happy to volunteer their shoe size. They're not so happy to volunteer their weight. So we did all kinds of pre-tests to find out what people would like to volunteer in terms of their data. But shoe size is actually a good proxy for height also, so there are interesting elements here. We also have some volunteers their zip code, and if they don't know that because they might be younger, then they can also enter their city, or even click on a map and identify themselves this way. But this way we can geolocate them, so we can give them a different base map as well. So currently we are implementing a scatter plot and a geomap. Ultimately, we hope that just like in Jeffrey Hare's implementation, people will be able to drag different data variables over to the axis to define a new reference system. Ultimately, they should also be able to identify what kind of data column should be encoded as color or as shape or as other data visual encodings. And the first runways are actually now set up. So the entire setup is about $150 just in terms of sensors if you have the monitors on site. So this also then travels very well to science festivals and other places. So if you're interested to have your own run exhibit with your own kind of data capturing and your own way of having people make their own data visualizations, please let me know. Now, going forward, I believe we are going to encounter more and more scientific data, also as data visualization experts. And one type of scientific data that I deeply care about is data that comes out of IoT setups, the Internet of Things. Indiana University recently created an intelligent systems engineering department, and I'm very proud to be one of the faculty members in that department. And thanks to NACFI event organized by the National Academies of Science, which brought together many artists and designers and engineers and scientists as well in 2015. I became familiar with Philip Beasley's work, and we are now using the data that comes out of these sentient architectures to help other people understand how these IoT setups actually work. For those of you which have not seen Philip Beasley's work, it actually was here on display as the sentient chamber in 2016. And so here you see some of the animations from that architecture. The entire sculpture is quite artistic. It's a quite central encounter to walk up to it and to kind of have these feathers kind of embrace you, to have potentially something whispered in your ear, to have these lights shine in certain areas. It's a very different encounter than just me pulling out my phone and doing some work. Ultimately, these environments are filled with sensors and actuators, and I think it's important for many to understand just how many different types of sensors and actuators are there, where they are located, how signals and energy flows goes through that sculpture. And you can also soon speed up and slow down time to really understand where processing occurs and really takes a long time, and what is rather fast in terms of signal to actuator processing. It's my great pleasure to let you all know that very soon we will have an installation at Luddy Hall to actually have one of Beasley's installations there. It's a more permanent installation, and it's quite beautiful also in detail. When I left Luddy Hall last Friday, this is how it looked like. So the installation is actually going to happen the next 2 weeks. And so we are all very excited to have that happen. But ultimately, it converts our entire fourth floor of Luddy Hall into a laboratory of IoT research. And some of my PhD students are now involved in developing augmented reality overlays that use basically a tablet setup to have you see where those sensors and actuators are, to have you slow down and speed up time to really understand how those IoT setups work. And we hope that's not only relevant for engineers which want to optimize these systems, but also relevant for artists, for designers, for us which really need to understand how we can design desirable futures using IoT and using many other technological setups. That's the end of my presentation. If you still prefer books over IoT setups, we have that as well. And we also have many of these slides online. Thank you.